Will you understand this problem? See, which is the keyword here?
Angular
Starts.
Because initially at rest.
Yes, initially at rest.
Yes, sir.
Yes. It is initially at rest and starts. Listen here. The body of round section starts rolling on a horizontal surface with uniform angular acceleration. So how will you look at it? Because they are told uniform angular acceleration. That means the body is at rest and then there is torque applied to this body.
Yes, sir.
Yes, sir.
Torque applied to the body and therefore angular acceleration is there.
Yes.
Right?
Yes.
But the initial angular velocity is 0 because you will say it is at rest.
Yes. Yes.
It is like this, the body is like this, you have put your hand and say 1, 2, 3, you start applying the torque.
Yes, sir.
So the initial angular velocity omega is 0 to begin with. Okay, and then you continuously apply torque, therefore the angular acceleration is continuous. Angular acceleration is continuous.
Yes. Yes, sir.
Right. So alpha is continuous. Find the initial acceleration of the center C and the top point E. See, initially the body is at rest. Okay. So you have given torque to this body and as a consequence there is alpha. So now it is rolling, means rolling without slipping.
Yes.
So the alpha, say now alpha you say it is in this direction. So therefore if you now take this center and this point is at rest and therefore the acceleration at this point, at the center. See, we have just now analyzed. What will be the acceleration at the center? It will have only one component.
Alpha.
Yes, sir. Alpha.
And that should be alpha.
Yes, sir.
Yes, sir.
Okay, alpha r I cap. This is what we are going to do. As far as the center is concerned, there is no this component. Now this is center. Now this point A, right? So this point A. So what will be the acceleration at that point? If you remember those vectors here. So one means this one will come here as it is.
Yes,
Okay. Plus you will have to take this vector.
alpha square.
And therefore this will be the acceleration vector at this point.
Yes, sir.
Correct? Yes or no?
Yes, sir.
So what is this? This vector is known alpha r, and this vector, if this is alpha r, this vector will be what?
2 alpha.
2 alpha. 2 alpha r I cap. What will be this vector?
Omega square t cap.
Omega square.
Omega square.
Minus
Omega square r. If you take, so you have taken here y and x. So this means this is j cap, and this is I cap.
Yes, sir. Yes, sir.
Correct? ಏನದು?
Yes, sir.
sir.
Yes, sir.
Exam? ಹೆದರಿದಾ? ಖರೆ?
ಇಲ್ಲ ಸರ್,
Who got scared, sir?
Arun is telling Dhiman got scared since the power went off.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. Demon.
ಕ್ಲಾಸ್
When in class.
ಗೇಮ್ ಆಗ್ತಿದ್ದ
Yes, sir.
ಮಷೀನ್
So acceleration of C will be alpha r I cap, and acceleration at A will be 2 alpha r I cap, both at time t is equal to 0. Now as the time advances, okay, that is for some time t later on, the acceleration of C, will it change?
No, sir.
It will not change. Good, you are confidently telling it will not change. I like it.
Yes, sir. Yes, sir.
But as far as A is concerned, here, so you will write it as 2 alpha r I cap
Yes.
plus omega square
minus
omega square
Function of
minus theta.
R minus
Omega square r
r
minus
minus
theta minus theta.
Yes.
Yes, sir.
Yes, sir.
right? But they are asking as a function of time.
So, like omega
Omega is alpha
will
t.
be
So
alpha t.
yes, so here you write 2 alpha r I cap plus
Alpha t.
r and omega itself will be what? Alpha t, because omega naught is 0.
0 is
Okay, alpha t
whole square.
whole square minus j cap.
Yes. Yes. Yes, sir.
Yes.
So you are going to get something like this, right?
Yes.
Hello, everybody else got it?
Yes, sir.
Yes, sir.
Yes,
Yes.
Right?
Yes, sir.
Okay,
Yes.
fine. So I hope we have done this correctly. We just check out what is that they have done.
Yes, sir.
Starts knowing, we have also considered the same thing. So we got A bar is equal to AB bar this one, so alpha is equal to 0. So we got AC equal to alpha PC, and of course we are not plugged in the values. If you plug the values, we are going to get this,
20.
right? Because this is 10 into 20, and acceleration of point A is 2 alpha 10, it is 40.
40.
And as far as the second equation is concerned, omega is equal to omega naught. Substituting, we get omega naught is equal to so and so. But further, we have substituted for this one, and we have got, right? So A will be alpha Ri plus minus so and so. Again, they have written the equation. Okay. So we have directly written this equation. Omega square R.
Yes.
Okay. And substituting this for omega, and omega value is alpha t. Alpha is 2t. Right? Alpha is 2t. They have written this and they have written this equation. Okay? No issues. And superposition method. I think both are same here. Superposition and this are same here. We have used both. Okay. Now using ICR,
We did that at XI.
we did that with ICR. Same ICR
Yes, sir,
method.
ICR.
Already we have used this method. For same or the same.
All are same.
Now in this case, all are same. But sometimes,
Same.
no, sometimes. Anyway, let's not first pick it. Handle this. Two identical discs, each of radius r, are connected by a cord as shown in the figure. Okay. The disc I rotates with constant angular acceleration alpha in anti-clockwise direction. See, this is a thread which is on this. Okay, and this is rotating anti-clockwise, so the thread is getting looser. Right? I rotate with constant angular alpha in anti-clockwise. Find the acceleration of the center of disk 2 and its find the acceleration of the center of disk 2 and the angular acceleration. आराम से आराम से करो, प्यार से करो. Understand the problem mechanism first.
Yes, sir. Nice. Yes.
Did that?
Yes, sir.
Did?
Yes, sir.
Yes, sir.
Good. Okay. Fine. Then first explain the mechanism. What are the concepts? Come on, somebody.
So, first pull if you take, sir.
First pull if you take.
Yes. Angular acceleration is equal, sir. That means the rope, sir, which is turned on, it is moving down with acceleration A is equal to alpha r.
First one is moving with A is equal to,
Alpha r.
this point is moving with A is equal to alpha.
So, successively the whole rope is moving with alpha acceleration.
So that means now, see, now you use the right concept here. Whole rope is moving same acceleration alpha. So you use the right concept here. Somebody, what is the acceleration? What is the acceleration that you have to consider here? Tangential. So the tangential acceleration at this point. Acceleration of the rope is equal to the tangential acceleration at this point of the disk.
Yes, sir.
And at this part of the disk. And here also the rope is moving, right? And as it is unwinding, what is happening here? This disk too will rotate clockwise and also do what? And translate. It will also rotate and translate. Correct? Disk 2 will rotate and translate. Hello, are you with me?
Yes.
Yeah. Sir, translation.
Yes.
Because this thread is becoming dhila, man. See, this disk 1 is rotating and there is a thread here. The thread starts coming down now. Dhila ho rahe ba? Pratyush,
Yes, sir. Yes,
this
sir.
is releasing the thread. So therefore,
Yes.
point C will start having translatory acceleration down.
Yes, sir.
Point C will have translatory acceleration down. Okay? So now, so now if you know this alpha, here, right? See, this alpha is known here. So this R is given here. So therefore, alpha into R becomes the tangential acceleration at this point. So if the
Yes.
tangential acceleration at this point is, then what is the, see, please understand here, no, this thread is coming down, it is coming down, right, it is coming down, and this point B is here, point A will slightly come down, right, and this C will come down. How will you relate now, man? How will you relate this alpha with the acceleration of the C? Acceleration of C is down.
Yes, sir.
Yes, sir.
How did you solve it?
So like that acceleration of C sir should be parallel to the tangential acceleration at that point A sir. So that will be alpha sir. The acceleration of center of disk will be alpha minus
As acceleration of which centers? Disk 2.
2 yes, sir. It will be alpha in the minus Jacob direction sir.
Okay.
And now we know acceleration of center of disk sir. When we divide that by R sir, then we will get angular acceleration of disk 2. Like they both will move with constant angular acceleration.
No, you see, now this is alpha.
This is alpha sir.
So what is the acceleration of C?
Alpha R in the minus Jacob direction sir.
Alpha R in the minus
Jacob
Jacob.
direction yes sir.
That is with respect, how?
Like that acceleration should be like that acceleration should be parallel to the point in. Like they both.
See, if this is rotating, gentlemen, if this is rotating and accelerating, then there are two components here. One is the component of acceleration towards, other one is the component of acceleration tangential.
Yes.
Yes.
So how can you say this is equal to this? Anybody else?
Alpha R by 2 in the downward direction.
ಏನು ಬರೋಬ್ರಿ ಹೇಳು ಏನು alpha by 2 ಅಂತ ಹೇಳಿದ್ರೆ ಏನು ಎಲ್ಲರಿಗೂ ತಿಳಿಯೋಂಗೆ ಹೇಳ
Acceleration of center of disk.
acceleration of center of disk will be what?
Alpha R by 2 downwards.
Alpha R by 2 downwards.
Yes.
Why?
Sir, here sir, I used NLM concept sir, because the acceleration of B is 0 sir, and acceleration of A downwards is alpha R sir, so acceleration of the center of disk will be the average of acceleration of A and B.
So you have taken B as the center of rotation, ICR. Did you take B as ICR?
No sir.
Then what did you take? Then how did you get alpha by 2 here?
So in NLM we had done this sir.
How you have done?
So that
How?
acceleration of C will be the average of acceleration of A and B.
How did you get there?
So that this one's the length of the string has to be constant sir, so we differentiate twice to get the relation between acceleration sir, and
You did like that.
Yes, same.
Can you not use whatever we did now and get the same relation?
So we'll take B as ICR, sir.
If you take B as ICR,
So if I
okay, then this is alpha.
tangential acceleration.
So with respect to B, the acceleration at A is going to be
Alpha.
alpha 2r.
Alpha 2.
Sir, only alpha.
Yes.
Only
yes.
alpha.
To B.
Sir, alpha, sir, but yes.
Alpha. So this is already given as alpha. Because this one we said the acceleration here is alpha, this is alpha. Okay,
Yes.
and this is half of it.
Half of it, yeah.
So this should be alpha r by 2.
Yes, sir.
Yes, sir.
Going by that principle, this will be alpha r by 2.
Sir, how many these ICS?
It will not.
Instantaneous, man, instantaneous.
So if we see that the rope is going on losing, sir,
Going on losing, fine.
that time.
See, listen. Going on losing, fine. See, now what happens here? See the mechanism. This will loosen up. So this will loosen up means what is happening here? Say this thread will come down. Okay. Then what happens? This weight on this the weight vector will be down. Okay. And as a consequence, what happens?
It will come down. Accident.
See, first of all, now this point is touching this point, and this point is touching this point. This point is touching, so this delafies. So this point A will lose contact, but B is still in contact.
Yes, sir.
P is still in contact.
Yes.
Then the weight vector, because now once this becomes theta, the weight of C will be down. So this weight vector into BC will cause a torque on this.
Oh, yes, sir.
Will cause a torque on this.
Yes, sir.
So this
Yes.
torque is what is going to give this rotation. Because of the weight of this second disc, it will give torque on this, and therefore this will rotate.
Yes.
Right?
Yes.
Because the
Yes.
torque will accelerate, and as a consequence, this disc will rotate. This disc will rotate. Okay? And because of that weight, listen here, because of the weight there is torque, and because of the weight there is also acceleration downwards.
Yes, sir.
And
Yes.
because it will accelerate downwards, this point B will go on shifting down.
Yes, sir.
This point B will start shifting down. Understand?
Yes, sir. Yes, sir.
Yeah, this point B will start shifting down. Okay? So that is what we do. Anyway, we'll see. We'll see the solution now here. And
Sir, torque due to weight.
pardon?
Sir, the torque due to weight, sir, it will be zero now, sir, totally.
Why?
Sir, because
See, now the weight vector is down here, and this
Yes.
point is to the string here, B point is here. So this is now BC. What is the torque? W into BC. This is the torque. W weight into BC. This is the torque. So this torque at this point will create acceleration. This will create acceleration here. Okay?
Yes.
And we just now found out that this acceleration will be alpha r by 2.
yes,
Correct? And this acceleration is, and here this thread is coming down. We said this thread is coming down, so therefore we got this acceleration down. And due to this weight, what is happening here? There is this acceleration, what you see here, okay, is also the acceleration component along that, and that will become translation acceleration. This here is translation. So therefore this point will come down. When this point comes down, the next point of the disk will be this. Sorry.
yes, sir, yes.
Yes, sir. So you have to first look at the mechanism. So the next point of the disk will be this, down here. Okay, so this point B will now complete. Okay,
Yes.
so that will also
Yes.
be accelerated. That's the mechanism.
Yes.
Yes.
Sir, so that disk will rotate clockwise, sir.
This will rotate clockwise.
Okay, okay, sir.
Yes.
That's why it is rolling without slipping.
Yes, sir.
Let's see, what is the solution there? As this die rotates, the thread unwraps. Acceleration of a point on the portion of the thread between the two discs equals the tangential acceleration at any point on the periphery of disc I. The extreme left point A of the disc 2 must also descend with same. This is wrong. The extreme left point B.
Yes. Yes, extreme left.
Point B. The left point B of this 2 must also descend with the same acceleration. Downward acceleration AB of point B is equal to tangential acceleration of point on the periphery of disc I. So AB is equal to alpha R, AB is equal to alpha R. Acceleration of B is alpha. The point B on the thread is at rest relative to ground, therefore it can be assumed to be that the second disc is in a motion similar to the rolling without slipping on a vertical surface. Now applying the condition, AC is equal to half AB. Got it?
Yes.
Is equal to half alpha. We got this. Angular acceleration of disc 2 will be half alpha. We got this right. Hello?
Yes, sir. Yes, sir.
Yes, sir.
Okay. That's all. What's the problem?
Yes.
And its angular, find the acceleration of the center of the disc and its angular acceleration. Okay. It is 8:30 now.